So how do we actually go about preparing a standard solution, you're probably asking now. So we've picked an appropriate material. So let's say for the sake of this, we've actually chosen sodium carbonate. We've actually kept this in the oven. We've put this in the oven for a while, and we've stored it in a desiccator. So I know that this is dry. It's actually free of water. Okay, and I can obtain this in pure form. It's got a very high molar mass. All's well and good. So what do we actually do? What we need to do first is we need to work out the concentration of solution that we actually want to produce. So let's say that I desire to make a 0.1000 mole per liter solution of sodium carbonate. Okay, that's cool. Let's work backwards. I know that my concentration is equal to my number of moles divided by my volume. Now, I know what I want my concentration to be. It's 0.100 moles per liter. We've got to work out how much of it we want to make up. So really commonly in what we have in the lab, we have these things called volumetric flasks, which I'm about to talk about. You can see them in a diagram here. They've got a really long neck. Commonly, these are 0.250 liters. They're a very accurate piece of glassware. So the only thing that we need to work out now is the number of moles that we're actually going to require to produce this 0.1000 mole per liter solution. So let's work this out really quickly. Let's rearrange the formula, and we end up with N equals CV. That's cool. So 0.1000 moles per liter multiplied by 0.2500 liters. Okay, notice liters and liters, inverse liters cancel. And if we multiply something by 0.1, we just move the decimal place. So we need 0.025, and don't worry about the decimal places so much for now. We'll worry about them at the end, moles. Okay, that's all well and good. But how do we get 0.02500 moles into our volumetric flask? We need a mass. So if we rearrange our N equals M on MM, we actually end up with our mass. Okay, I'm just going to get this up on the other screen here just so you guys can see it. Our mass here is actually equal to our number of moles multiplied by our molar mass. So you can see how this is all starting to come into play. Okay, our number of moles is 0.025. Okay, our molar mass in this case is sodium. There's two sodiums. Okay, so 2 times 22.99. Okay, our carbon, so plus 12.01 plus 3 oxygens, so 3 bracket 16. Okay, and I don't want to go off the screen here, so this is in grams per mole. Okay, moles, inverse moles cancel, we end up with grams. Okay, so let's do that really quickly on our calculator. 0.025 multiplied by 2 sodiums, 22.99, plus 12.01 for our carbon, plus 3 times 16 for our oxygens, and we end up with, we need 2.64975 grams. All right, so now we know the mass that we need to weigh here. So we need to weigh out 2.64975 grams of sodium carbonate, and sodium carbonate we've already told you is an appropriate thing, an appropriate primary standard. But the problem we're going to run into here is this: most of your scales look like this. You only have 2 decimal places on the scales we have at school, so it's actually impossible to weigh out 2.64975 grams. So you're probably thinking, how do I get this really, really, really accurate 0.1000 mole per liter solution? You don't. All we can really hope for here, right, is to produce something around there, but it's not going to be exactly that. So what we're going to do is you're going to weigh out, I don't know, let's say that this is approximately 2.65 grams. That's doable. We can weigh out 2.65 grams. I wouldn't get too caught up in weighing anyway. If you get 2.64, 2.63, 2.66, who cares? As long as you know what you got, it's fine. We then can work backwards again, and we can actually work out what our concentration will be. So let's say we had 2.65 grams. Well, C equals N on V, moles per litre, but we need to work out number of moles out first. Mass on molar mass. Okay, our mass is 2.65 grams now. Let's say that's what we weighed out. Okay, our molar mass again is 2 times 22.99, okay, plus 12.01 plus 3 times 16 grams per mole. Okay, sorry, let me just put that down there. If we go and do that in our calculator now, we have 2.65 grams, 2 times 22.99 plus 12.01 plus 3 times 16. You end up with 0.02500235871 moles. Okay, which is a little bit different to when this was all zeros just before. Not the biggest issue in the world, it just means our concentration is going to be a bit different, but once again, as long as we know that. Okay, so let's use this number now and let's use this formula to work out our new concentration. Our concentration now is our number of moles, 0.02500235871 moles. Our volume of our volumetric flask, like we just talked about before, so this piece of equipment here is 0.25 litres. Okay, so we divide that by 0.25, it's the same as multiplying by 4, and we end up with 0.10000094349 moles per litre. Now, so you can see that not being able to weigh this out to this accuracy changes our concentration that we wanted, but only a little bit here. Now, the truth is, our most limiting calculation was this. Our most limiting number we used for a calculation was this anyway. So if you're actually going to go and report the concentration of this, the truth is you can only really report it to 3 significant figures. We weighed it out to 2.65 grams. So I can report this now as 0.100, that's my 3 significant figures, moles per litre. And it's hard to do otherwise. If you have more, decimal places on your scale, you might be able to do that to another significant figure. But that's how to calculate how much to weigh. Let's look at the rest of the process here. Once you've actually weighed out your sample, so we're going to weigh 2.65 grams of the sodium carbonate out. We're going to dissolve it in a beaker in a small amount of water using a stirring rod. We don't want to use a huge amount of water because in the next step you're going to pour it into a volumetric flask, and if it goes up here, you're in a little bit of trouble. So we're going to dissolve it, completely dissolve it, because once it's in here, it's not going to dissolve. I'll get you a video on someone actually doing this later. When we pour it into the volumetric flask, we want to make sure that we rinse our stirring rod with the beaker. We want everything that was in here and here, we want it all to end up in here. All right, losses means that we have errors. So we want to rinse off that stirring rod. We want to use a funnel, and we then want to actually take a wash bottle like this, and we want to rinse the stirring rod, the beaker, and the funnel again to make sure it all goes in there. Okay, that's what they're doing in this step here. What we want to do next is there's a little calibrated marking, and it's not so well shown here. You see this little line here. There's a little calibrated marking on our volumetric flasks. Generally with volumetric glassware, the narrower the neck is, the more accurate it is, because the distance that the meniscus moves will be greater when it's narrower, so you've got a little bit more control over it. What you're going to do is you're going to use a pipette after this, and you're going to drop till it comes up to the calibrated mark. Now, on your volumetric flask, it's a really poorly drawn one, you're going to make sure that your meniscus sits like this. So the bottom of your meniscus is on the calibrated marking. Once it's there, you're going to stop. You're going to stopper your flask, and you're going to invert it, turn it upside down with this in your palm, and you're going to shake it. Okay, making sure that the stopper part is in your palm so it doesn't go everywhere. And that way you've produced a very, very, very accurately known concentration of solution, which we then call a standard solution. Now, if I want to go and standardize some hydrochloric acid with this solution afterwards, I can perform a reaction, with these two, and I can wait for my sodium carbonate to neutralize my hydrochloric acid, and I can measure the volume and so on and so forth. But that's a little bit of year 12 stuff. So just make sure you read through here, preparing a standard solution. That's what we just talked through there. This is what you need to know, and it's in the exemplar document.